Now I'd like to show a video of the ULA crew building up the Atlas V launch vehicle and mating the TDRS-K spacecraft at Slick 41. Please roll the tape. Here's a nice shot of the Mariner ship that transports hardware from the ULA factory in Decatur, Alabama. This is a shot of the TDRS-K second stage Centaur being offloaded here at Cape Canaveral Air Force Station and transported to the ASOC for ground testing. A beautiful shot of the Antonov aircraft. The Antonov is used occasionally by ULA to transport the rockets, both the Centaur and the first stage. Here you see the TDRS-K first stage being offloaded at the skid strip at Cape Canaveral Air Force Station and being transported over to the same facility as Centaur, the ASOC, the Atlas Space Flight Operations Center for ground testing. Here we are early on the morning of January 3rd in the fog out at the VIF near Slick 41, erecting the first stage onto the mobile launch platform. You see the professionals of United Launch Alliance connecting the overhead crane from the VIF and putting the first stage booster in the vertical position. You see the first stage engine there, the RD Amros RD-180 engine, thrust of 861,000 pounds, being lowered down onto that MLP. On Saturday morning, on the 5th of January, we brought out the second stage, the Centaur, rolled it from the ASOC out to the VIF for the same erection activities as the first stage. You'll see the erection sequence beginning here with the attachment, and the second stage Centaur is powered by the Pratt & Whitney Rocketdyne RL-10 engine with a thrust of 21,900 pounds. You see it being carefully positioned onto the forward end of the first stage and lowered and mated into position. And here we are, just over a week ago, the early morning hours of January 20th, the TDRS-K spacecraft, encapsulated in its payload fairing, left the Astrotech payload processing facility in Titusville and made its way out to Slick 41 at the VIF for mate to the Atlas V launch vehicle. You see the encapsulated assembly being lowered down onto the forward end of Centaur and mated. The TDRS-K launch campaign has gone very well to date. Over the past week since that TDRS-K mate, the Atlas V team has been busy with launch preparations. Last Tuesday, on the 22nd of January, we performed the final integrated systems test with the spacecraft and rocket together. Last Thursday, the combined NASA and ULA launch team held the flight readiness review, where we assessed the preparations and readiness of the Atlas V vehicle, range assets, and the TDRS-K spacecraft. Last Friday, we performed a mission dress rehearsal to exercise and prepare the entire ULA, Air Force, and NASA launch team. This morning, we conducted the launch readiness review for the TDRS-K mission. Senior managers from NASA Kennedy Space Center, Goddard Space Flight Center, and NASA headquarters, as well as ULA and the Air Force, assessed the readiness of the rocket, the spacecraft, and all range assets to proceed with launch on Wednesday evening. Tomorrow we'll begin our final launch preparations at approximately 10 a.m. Eastern Time by rolling the Atlas V vehicle on its mobile launch platform approximately 1/4 mile north from the VIF to the launch mount at Slick 41. We'll then fill the first stage fuel tank with highly refined kerosene known as RP1. On Wednesday, the launch team will begin arriving on console in the afternoon hours Eastern Time. The crew will perform all final preparations for vehicle power on and electrical checks beginning in the afternoon hours about 1:30 p.m. Eastern. We'll follow that later in the day about 6 p.m. with cryogenic tanking of first stage liquid oxygen, as well as the second stage Centaur liquid oxygen and liquid hydrogen. Final engine slews will be performed after tanking, and then we'll be ready for launch Wednesday evening at 8:48 p.m. Eastern Time with a 40-minute launch window. In summary, the Atlas V rocket and range equipment is ready, and the combined government and contractor launch team is prepared and excited to launch this critical national asset, the TDRS-K spacecraft. Back to you, George.
Thank you, Tim. And now to Vernon Thorpe, the Program Manager for NASA Missions from United Launch Alliance. Vern?
Hey, thank you, George. ULA is honored to be here today, just 2 days from the launch of the TDRS-K satellite. Since we began building this vehicle in Decatur, Alabama, nearly 2 years ago, and through all of the engineering, the production, and all of the processing down here at the launch site, we worked with NASA and our other mission partners to get us to this point, and on Wednesday to a successful launch. The vehicle that will launch TDRS-K was prepared in just 27 days from its arrival at Cape Canaveral Air Force Station. That's a record processing time for an Atlas V vehicle. When the Atlas V program started, a typical processing time was on the order of 60 to 90 days, and as the team gained more experience, we were able to get that down to as few as 44 days in the past. The 40% reduction down to 27 days was possible due to the continued growing experience of our team, and also the results of a major initiative in 2012 to reduce processing time without adding any technical risk. We called this initiative Launch Span Reduction, and it offers our customers added manifest flexibility to meet their schedules, and it also offers additional launch opportunities to ensure that payloads can be launched on time and reliably. In fact, as a result of reducing our span times, we were actually able to insert an additional mission into our 2013 manifest. TDRS-K will be the first of 13 ULA launches planned in 2013. As Tim mentioned, it'll be the 35th Atlas V mission. It will also be the 67th mission that ULA has flown to date. This mission will be launched aboard an Atlas V 401, which uses the 4-meter metallic payload fairing. It has a booster powered by an RD Amros RD-180 engine, and the Centaur upper stage will have a single Pratt & Whitney Rocketdyne RL-10A-4 engine. This mission will not require the use of any solid rocket boosters. And now I'd like to show an animation that will give you a preview of what we expect to see on Wednesday evening. That's what the Atlas V 401 will look like on the launch pad. And at liftoff, the booster engines will generate almost 900,000 pounds of thrust to get the vehicle off the ground. And for this configuration without SRBs, the first major event that you'll see during the flight will be about 4 minutes in, when we've depleted the propellants in the booster stage and we shut down the booster main engine. You'll see that coming up here shortly. Once we shut down the booster engine, we'll separate from the Centaur upper stage about 6 seconds later, right there, and we will begin preparing for the first of 2 Centaur main engine burns. The first burn for this mission will last approximately 14 minutes. 10 seconds into that burn, we'll jettison the payload fairing, since we're pretty much out of the atmosphere by that point. And that 14-minute burn will put Centaur with the TDRS spacecraft into a highly elliptical orbit. The perigee will be about 99 nautical miles, but the apogee at that point will be over 13,000 nautical miles. Following that first burn, we'll coast for 82 minutes, then we'll do the second burn that you see here. That second burn will only last about a minute, and that will put us into a geosynchronous transfer orbit. 6 minutes after that second burn, we will reorient and separate the TDRS spacecraft. Total mission duration up to that point will be about 1 hour and 46 minutes. And then following that separation event, we will perform the normal contamination and collision avoidance maneuver and put the Centaur into a safe orbit so there's no chance of recontact with the spacecraft. ULA is proud to serve a critical role in delivering NASA payloads to orbit, and we're focused on perfect product delivery for this and every mission we launch for NASA and our other customers. Our focus is on successfully delivering important capabilities to orbit. Launch is just the beginning of this satellite's journey, and the addition of TDRS-K to the overall constellation will continue the successful legacy of the project and strengthen NASA's communication system that's so vital for the International Space Station and many other satellites that are in orbit today and will be in orbit in the future. In fact, even the rockets that launch these satellites rely on the TDRS constellation for receiving and returning the telemetry data to help us understand how to make these rockets function even better in the future. Once again, I'd like to say thank you to all of our mission partners, and with that, I'll turn it back to you, George.
All right, thank you, Vern. And now to TDRS-K. And to discuss the satellite is Jeffrey Gramling, the NASA TDRS-K project manager. Jeff?
Thank you, George, and good afternoon, everyone. We're very excited to be here this week to launch the TDRS-K satellite. This will be the 11th TDRS satellite that we've launched, but it's been a long time. It's been 10 years since we launched the last one. We launched TDRS-H in 2000 and I and J both in 2002. HIJ and the KLM series of spacecraft have all been built by Boeing in El Segundo, California. So we arrived at the Cape about December 18th, and I've got a video here to show you what's transpired since we've gotten here. So if we can roll the video. So what you see here is the spacecraft was flown on a C-17 provided by the Air Force, and it landed at the Kennedy Shuttle Landing Facility, and we're offloading here. And that's the shipping container, which was then taken to Astrotech in Titusville, where we did spacecraft processing, which included testing, fueling. As you can see, it's very delicate operations to unpack the spacecraft and mount it on the test fixture. So at this point, obviously, the spacecraft arrived with a single-axis antennas furled for shipment to the Cape, and then also will remain stowed until while we are encapsulated, and then deployed after we separate from the Centaur on orbit. But you can see the two single-axis reflectors folded one inside the other there. And here, of course, you can see the two halves of the payload fairing being encapsulating the spacecraft, and then we rolled out about a week ago, a little more than a week ago. We rolled out from Astrotech and were transported to the VIF, and you saw the footage that Tim showed of us being hoisted and then mated on top of the Atlas Centaur stack. So things have been going very well since we arrived on December 18th. The spacecraft is ready, and I've got one more clip to kind of fill in the gaps. Vern showed you the sequence up until TDRS spacecraft separation. So now we've got one animation that kind of shows you what happens after that, which is interesting, I think. So as I mentioned, after we separate from the Centaur, the first thing that we do is unfold the single-axis antennas so they don't take a set. They're composite fiber that Boeing designed for this mission back on HIJ. And here you can see the single-axis. Well, first thing you saw was a solar array, one solar array being deployed, and then the two single-axis antenna booms, and then the second solar array. And following that, right now what you see is the forward Omni being deployed, and then the last deployment that you're seeing is the Space Ground Link antenna, which is the antenna that points at White Sands, New Mexico, where our ground station is. The two large single-axis antennas are the high bandwidth channels that we have to user spacecraft, such as the space station, space telescope, and those are gimbaled, and they track the users to allow for the high bandwidth data connection that we provide.